Hello, everyone. Let's see if I can just broadcast this a bit. Yes. All right. Now I'm going to look at this. I was playing around with the thread stuff. So let's just roll back that for now. And let's see. Okay, I got some other stuff here as well. Let's see here. Right. Okay, now let's see what we got here. So now I actually got the actual thing that broke. So let's see here. So we get a simple struct is line 1. Yes, with alignment I am, it could be things going wrong. Right, so he wants to align it to 1, and there are 10 bytes, and we have u short and u long. That should be 10 bytes long. Yes, let's run this. Oh, I started the unit test. Let's just run this example. And I do believe, okay, so what happens? It's gives an AA for the B, right? And it should be having, this should be in B, so why is it printing AAA, right? Let's see here, it's a hex, right? So that's correct. So let's see what happens if it's not aligned, right? It's like this. And we will then need to insert some more data here, right? So 1 2 3 8. Okay, so that's like this, and now we're instead doing 16. So let's see what happens here. If it gives you the right. Oh, too many elements. Yes, of course. So okay, this one gives us the right behavior here, right? And let us see what happens. So we're gonna look at the IR for this. So let's again. Wait, it's aligned, but is it packed? It's not packed, is it? Right. Align 1 does not mean packed, so it actually works. Okay, I'll just type that. Right. So let's see here. So wait here. Where are we? Like there. Okay. You didn't use packed. So that was why. Okay. That was a quick one. Right. So yeah, maybe somewhat surprising, but if you think about it, it's going to be like what happens really is like if you get the size of here. So I can write the size of print and a simple struct size of, right? So in this case, when it's packed, we just get the small size, like the way you want it. But if we don't pack it, it's going to behave as normal. But there's going to be like you can place this, you can offset this. So essentially, if you place this one in another struct, so like this, so other struct, and you place a char first here, and then you place a simple struct b here. In this case, since the other struct is, this might seem like counterintuitive, like this one will be like 17, right? Let me see. I think that's it. Oh, it's 24. So let's see. What? That doesn't make sense though. It should have been. That's wrong though. That's wrong. It should have been 16 plus. It shouldn't have aligned that one. So actually, this is the bug. But that one, the one that looked at the pact, is not a bug. At least it's not a bug in the sense that it's doing something other than it was supposed to do. So it's just saying that the alignment of that one. It's just going to, like, if I do like this, a simple struct s, and then I kind of look at the IR. Let's see if I can have the IR here. Yeah, it's already meeting the IR. So let's see what happens with the S here. Oh, I already have an S. Okay, SSS. Okay. Now let's look at the output, and that one is called. There is no name, so it's the debug stuff. Here. So let's look at that one. Oh, it's getting alignment 8. That's wrong. Okay. Then I'll have to look at that. So, okay, we are going into the compiler and see why it's doing the wrong thing here. So, it's back in when you do the sema for the structs, right? And the struct member like that. We can go back for this. And we are not in a union member, we are doing the struct member. Okay, so we start with a default alignment that is 1. And it's not packed. And then we're going to go through these. It is a bit strange that it's aligned 1 and doesn't have, and isn't packed though. Like, maybe packed should always be implicitly aligned. Because I would like to just fix this, basically. I'm just going to open another window here and see what I think. Like maybe GCC is basically saying that packed is implied. Attribute aligned and packed. Let me look at that. Okay, so it has specifying alignment attributes and types aligned. It's a minimum alignment. Yes. Oh yeah. I forgot about this. Right. So basically, aligned says this actually follows GCC. So aligned says what is the minimum alignment? What is the minimum alignment given everything? So if it's if you have something inside that has bigger alignment, then the alignment is that. Um, so it's only useful for actually increasing the alignment, not for lowering the alignment. If you want smaller alignment, then you have to do like packed. Yes, and that is like how GCC does it too. Um, I could change that definitely, but that's just it's just the way it works, and I forget this too because I rarely use this, but yeah, that's the way it does it. So yeah, basically here you need to have if you do it just to have packed here. I mean the packed is a line one implicitly. So this is basically let's have a line one of the struct and everything in it. Unless something inside of it actually forces some other alignment, which it can do. So I think if I have like a line 8 here, let's see what happens there. I think this kind of, I don't remember what the alignment is, so let me just print it out. So print of the, let me have the alignment of the a simple struct line of, and then a simple struct size of, right? So in this case, we get like the alignment is 8, right? It's gonna grab the alignment here of this one here because it's enforcing that. You can you can do it like this. It's packed, and then you set the alignment on some other small thing in there, and then you have like this alignment for it's gonna be like. Do you everyone see this like 4 and 12? I'm just gonna look at the chat. No, no. Maybe it's on elsewhere. Can you provide a warning when we just put a line without packed and we have another struct number that does not follow largest to smallest by side? No. The problem, or the problem here is, and I think this is what like the GCC tries to do, is that what you want to do is like if you have several different architectures and you write the code assuming that the alignment is going to be like 16 or 8 or something, like you can write the code once and let's assume it's 8, and then you have like like this something variable that happens more in C, but also in C3 if you have like lengths, pointer sizes and stuff like that on 32-bit and 64-bit, right? And then you want to make sure, okay, I'm assuming it's going to be 8-bit aligned, and so I want that. Or I want it to at least be something aligned, and it could be smaller and larger. And then you want to have that minimum, right? But of course, we could just, we could introduce, min align, min align like this, right? And then we can go with, then we can have like align actually being implicitly packed, right? And then now everyone is happy. But the way it works with packed is, it is kind of odd in the way that, I mean, as soon as you do packed, everything like here loses its alignment. So you have to align everything the way you want it, like 16, sorry, or it will just be unaligned. So it's kind of, I guess it's like this is the, I'm sorry, but this is the way it has to be pretty much, unless we have like a whole different way of setting up struct. But then once you do that, it's going to be like everyone from C is going to have to learn that. So it has to be super intuitive. I don't have any idea how that should look. Like maybe if you rework everything from the scratch and kind of say like how you want to think about this or something. But the way it works in C and GCC handles it, it's kind of makes sense once you start thinking about it, but it doesn't make sense if you don't. To begin with, like, yeah, I said a line one, why can't I get the line one? I mean, because basically that means it has to be packed and everything else has to be aligned one. You know, so I mean, you could say like, okay, let's say, max align. So instead you have like this max line, and that one, if you set max line up to one, basically it's packed, and then everyone else, like, let's say you have like four. Yeah, maybe. I mean, you could say four, and then everything we get like four, 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 and it's not packed. It's like just four. It just has four for everything, and then all these things were like implicitly before. It's an idea. It's an idea to have that, and then you can like even reduce the alignment for some things if you want, and the whole struct will be four anyway. I don't know, maybe it would kind of work. There's but I for this I wanted to just match C. Sorry, I'm a little bit tired. I mean, you could even have talk about offsets or where you want what kind of offset you want things. But okay, that was it for that particular problem, I think. So you have, if you don't have things right, you can always, if you think it's going to be like, if you do like this, so compact. If you say it's going to be compact, like, and you say align one and compact, and you don't have anything else here and here, then this one should be complaining like heck, right? Yeah. So it's kind of like 6 bytes of padding would be added to align this member, which is not allowed with no padding and compact. So, so in this case, you would see it immediately, so you can kind of see why it does this. All right. Yeah. Well, let's see if there are some. I'm just going to look at whether there are any urgent issues. Passing variables in line assembly. Okay, that was this question. Does not handle structural alignment correctly. That was the one. I don't. That's um, all right. And let's see here. Test runner make hot reloading work. That's a different, longer thing. There are some things. So let's go into something else, right? Let's talk about language design a little bit, or feature design for C3. So recently, what we've been talking about is the generics, right? So the generics right now is if I make some, let's say I have a list, right? So a generic list, we can have a function here. So, right, so we have function and we want to make a generic list, and then we do it like this, right? And then you can do init on it and stuff like that, and you can use it like this, and we'll assume that you want to have heap allocation. Then you can push things into this list, and you have to import more. So let me import everything, the whole world. It's useful for this. So now we can print this, and we get a list which is like down here you see 1-4, right? Like this. So this is the generic list. So it's been a bit trying this syntax, right? Like this, int like this. Okay. So to be fair, it's not that bad. It actually is more readable, in my opinion. But it also looks very, very, very like it's kind of big. Just like the list, this one is also big. So this is kind of, when I say big, it means it takes like a lot of, it looks like a big thing, like a big feature. And that's kind of unfortunate. And people are like, why did you have to add these parentheses? And then you have to explain why. Because you don't want the ambiguity of that. And if you have something like this, it's also kind of looking very, very outlandish. It doesn't look like any other C language, C-like languages or algo-like languages. It just like looks like it just got an idea like this would be look cool, and that's kind of unfortunate, and it's kind of also big. It's it takes a lot of room. If you think about something like a list and a list, it's just, this is not like dooming it, but it's just saying that it's not. If I have something like this, there's a list, and inside of that list there's a list, and this is not weird or anything. It's like it's a normal thing. You can have a list and a list. And then it kind of becomes this blob, and that's fine, but it doesn't really help readability, and it's like it's not, because we're adding this, but and usually, like I keep saying that LL1 is if you have LL1, that helps readability, but in this case it doesn't do that. In this case, this one, because it's such a odd thing, it kind of makes people stop, because the parentheses are usually made to mean nothing. So, and people have been like going for this one. Actually, this one's better. The reason why this one is better is because kind of it's the parenthesis in this case is kind of on the inside and doesn't feel as obtrusive. But it's not great, but it's like, we can compare it, and you will see, perhaps, you might agree or disagree. It's not that something that I will be recommending, but just says that this is kind of, now it looks, because of the highlighting, you can't really see it, but you can compare it like this, right? So you can kind of see how maybe you can see that. Maybe I can make a string or something. What happens if I make a string here? I would say x equals string x. What does it do? Maybe I can get some highlighting or something. Oh, that looks a little better. Okay. Yeah. So this is kind of, if you have the parentheses, is kind of breaking up the reading, at least for me. And in this case, it's kind of on the right side. You have this thing, and then we have like the parentheses inside, and then that's the way you're supposed to do it. But it's not great. It's not great. So we were talking about this, which is just it for the main thing. Let's add here so people can see. So I can add some of these in as this like this, right? So without breaking the highlighting too bad, so we can kind of do like that. Oh, maybe I should look at the chat to see if anyone has questions. No, right. So so we can do the same thing here. So again, we have a list, and then we have an int, and this is smaller but also kind of more readable. At least I think it's more readable. Even though you don't do that, it's kind of, if you, let's have some spaces here, then you can kind of figure out, which one makes it more natural. But again, this is kind of ambiguous anyway. It's not, well, you can probably make it work. I mean, this kind of you can make work, but you might want to think like, okay, let's have parentheses. Like, could that work? And then it turns out it can't. But it's also kind of not super readable because these kind of float into each other. You can have the idea that maybe you want to have like this. But again, it's like not so nice. Actually, it's not bad, but it's not super. It's not worth. If this was possible, if this was, if like this or this one, if they were possible without any ambiguities, I would go for them, even though I don't think they're great. I don't think anything is great, but I would go for them because that would be simple and doesn't have all these extra, made up syntax that is completely new. When I say made up syntax that is completely new, I kind of mean people haven't seen that, and they come to the language and kind of, what does that mean? What can I even imagine what that, why is it that added? And I want to avoid that question, but I also want to avoid the problems where kind of reading the code you kind of get stuck on parts, and I think you kind of get stuck on the current, this one. Actually, I have still have, I've seen this for so long now, but I still have problems. It still annoys me, and that tells me that maybe it's bad. It's not. I don't care about when it looks like nice. I just care about whether it looks readable. So we talk about recently. There's like this idea. Now this one has a problem because it's kind of ambiguous today. We have we are using that for this kind of thing. So we can do like a now this is not valid here in a function, but we could think about initializing a struct like this. So this is kind of nice, but because I mean in C you would have to do like this, right? So this is C, the C way. And the reason you don't like this is that if you have something, let me have like this, right? So you can do like this in C. But if you want, okay, I kind of kill, okay, but I still use X, all right. But if you want to reassign it like this, you can't do that. You have to like do this and redeclare it, which is a pain in the ass. So you kind of have all these over and over again because you have these. It's much nicer to have this in the parentheses. But in C3 you always have this, so you almost never write this kind of thing. So initially that wasn't the case, but I added more inference, and basically that's the case now. So that means we don't need that more like this slicker syntax without parentheses. So we don't need this anymore, which means we can use this syntax. So it's possible. And Julia, I know Julia is using it, and but that's about it. And it will look like this, right? So I don't know if this is good or not, but it's kind of readable to me. It's bad in the way these are bad. Actually, these are bad too, in the way that you kind of, it's hard to make out what's happening, right? You could perhaps make it better by doing the spacing, which is more natural for these than perhaps At least I don't have these spaces here, but I do have spaces with the braces. So maybe that makes more sense to kind of write it like this, and or maybe not. That looks weird too. And you probably, I know, yeah, I know. So this is a possibility, and the reason I would like to go with this perhaps is that it's like it's you kind of okay. He reused this brace syntax for generics, whatever. So it's not like in here, like oh, he made up a new combination of symbols to do that. No, I'm just reusing this, and I mean that's why this actually is better. This one is better than this one, the one above, because this one is kind of yeah, he made like this kind of thing between it, but I can understand it as kind of this kind of thing, right? So it's like a dollar between and then a generic. Yeah, I can understand that. So something like that. So actually, these are they can pick either of these. I could have these as well. This one is possible. I mean, of course, you would have it like this. But these are the options. So they're kind of equivalent. But and then people are like, why don't you do this? Right? Why don't you do this? Everyone is doing that. I mean, C++ started with this absolutely piss off bad syntax for a C language. You know, if you are changing the shift, you have call it like shift right or something like if this operator, if this is just it's not a symbol. If you have like the shift right or something, or shift left and shift right, some languages do. Then this is not a problem. You can have this. This is no problem. But if you have this operator, now your grammar is like looks stupid, and that's not thinking about like problems like one or something. I have something like one parsing this thing. Um, so actually, yeah, I've already looked at doing this because you have in this kind of case you still have somewhat that ambiguity. Not as bad, mind you, but it's still kind of bad because you have to semantically check it. But it's also doesn't feel like it's worth it. I mean, when you can do this, and suddenly it kind of yeah, it's I mean it's working, or even this, and this shit is. I mean, I don't know what possessed the C++ committee to think that this was a good idea when they had this this operator. It doesn't make sense, but if it had been like this, which is also something we discussed on the Discord, it would be easy to parse. But yeah, but it's not that. But then again, I mean, it's parsing C++ is like not for the faint of heart, right? What's the expression? Anyway, so that's kind of the thing. I'm what I'm thinking about, like when it comes to this, like readability. So it's like readability. Now I've read a lot of this code with this, and I don't think it's like easy to scan. So that's a bad thing. So that's why I want something else. And then you kind of want familiarity. That's great if you can have that. It's not a must because people get used to anything. But I don't want it too big. Not too big, basically. Because having something big is kind of really shouting at the users. So if you can avoid that, that's good. There was another question request actually, and that was to remove this thing here. This, I don't know if you used it, but this is the expression block. So we can do it like this in A, and then we can have like now this is going to be super boring because it's going to return the same thing. But if let's have a B here. So if B is larger than 10, then return -1. Otherwise, return B times 10, right? And then we're gonna print this what A is. Yeah. And this thing here turns it into a kind of, this is like an immediately invoked lambda, basically a closure. It works like that because the return here is returning here in the equals and not returning from the main. So let's just see how that works. So I'm just going to have that, run it, and it says -1 because B is larger. And if I have like, 9, we're going to see like 90. Okay, let me just see if there are any questions, by the way. So, the chat. No questions in the chat so far. Please go ahead and ask me questions because that makes it more fun. That makes it more interesting for me. Otherwise, I'm like, are you even listening? even though I see people are there. Okay. So in this case, first of all, I want to remove features. So removing features is always good because the language is simpler to reason about, simpler to write tooling for, simpler to learn. So putting more features into a language is basically bad unless those features are making kind of removing corners. So let's say, what should be an example? Okay, so in the case of compile time variables, for example, the fact that you can kind of you can look into a constant array, and then you can actually set a constant array. Setting the constant array, that's a feature that we added recently, but that is setting that constant array is actually not making the language hard to understand, just removes a special case, where the special case is that you can't set it, right? So it's making it simpler. So maybe we are going to make it possible to set structs, constant structs as well. It's not there yet, but maybe. With that, is removing corners and special cases. This is about a feature that's adding some feature that you have to learn. So what is the use for this, right? And one, actually, my main idea was not to use this for assigning values. No, it was actually this, something like this, right? I wanted to do like if test something, if that, then return. If blah, then return, and then do something. So kind of let me put some guard statements in the middle instead of like having to, like the alternative to this would be if test something and if test something, or and also not test something and not blah. In that case, do something. And sometimes you want to kind of calculate stuff. So it's like, it's more like in B is foo, int c is bar, and then like b is greater than c, or c or bas. In that case, return. So then, the if statement here would be very annoying to do. It would be like, instead now we have, so it becomes like, if test something, if not test something, then we are going to do this, right? So this whole thing, and then we continue. So then we have to do, if this is less or equal to c and not bas, in that case do something. So like, if we just look at that code and compare them, this is kind of more straightforward, because this is like what you would do in a function where you have God statements, right? You would like just do that, and then if you choose not to, then you can just bail out. And this is what that one, it does that. But there's a but here coming. We added this one, and this one has very little use actually. This is like do while 0. You can write this one as do while 0. I just added the do, which is a kind of do while 0. And if we have that, look, we can do this, right? The break. Ooh, we don't need the expression, this one, for that particular task. So now we actually, I just killed that. And before it was like, okay, yeah, but what if we're inside something? Like we're inside a switch. We're inside a for loop, like int 1 equals 0 and we're testing for something I, so like down like this, right? And now it suddenly becomes more complicated again, and we're doing like I here, right? So we're going to get those I's here and here, right? Oh, now it's more complicated, and in the case of C, you would have a goto here. So you could have this one, instead of return, we would have a goto, and we'll go to here, some done or something, right? And we can't do that if you are, and it's kind of, actually that's kind of icky in C, because it's like, it's not very clear what you're jumping to. So didn't want that. I didn't want the jumps. I wanted to have like, okay, let's have this formalized jumps, right? But look here. Looky. If I do the same thing here, let me just copy paste this. And then we name this do. You call it loop. I don't know. But we can do break loop. Right, and we are fine. Still works. So this use is completely subsumed by this one, the do. So that leaves us with the original thing we had somewhere back in time, with this kind of case where we have a we're going to assign something, and we can look at some of those examples in the source code where it's actually used. So I'm going to search. You can see this, I think, because we are doing this on a different window, but I'm going to jump there soon. So let's see the pipe. I need to search in the right directory too. So here's one, sub process. Okay, so in this we are going to check if it needs an escape, right? So doesn't need escape. So if let me see if anyone has a question. So first time we are listening, or at least I'm okay, good. Right, and I'm just gonna look at Discord here. If anyone is asking questions, you are free to ask on the stream, on the in-stream channel on Discord as well. Okay, so in this case, what we're doing here is kind of an inline function, right? This is kind of an inline function. And we to do that in this kind of this do style, you still would have to be like needs escape, right? And we have to we put the new in it on it because we are not going to get the default. Or maybe we could have the default. Basically, we could have a default that is false. But let's not do that for now. And then we do like do again, and we have some end. We have I do this for each. Just let me copy it in here. Oops, I shouldn't have removed it. So there we go. And in this case, we're gonna break. We're gonna set it to true. Needs escape equals true, and then we're gonna break to end. Right. And then if it's not true, then we're just gonna set it. Needs escape is going to be false, right? So now we have done the same thing. It's just the unnice thing that we have is the fact that wait, why does it complain about no wind? Okay, anyway, so this is oh yeah, probably this one. Yes, yeah, so it's giving me an error on this row because but this is the one that's broken. Okay, so here we have the same thing. So here the clarity is more of a more clarity, but this one is yeah, it's just simpler for this particular use. Possibly. I mean, it's the bad thing is that you have this variable here that you have to declare outside. It's not a huge problem. So what do you do? Like you could say, okay, why don't we do this? Right? We could do this. Definitely this could be done. So we can have like do end, right? So and then we break end and we set true. Right? We add now we're adding, values to break. Right? People are doing this all over. Yeah, that makes sense, but except that when do we actually use this? Right? It's now we probably want to add the same thing to like if and everything else, and it's just like barfing on the syntax here. I think it is not very. It's like it's making the C code very unCL-like. Actually, I don't even like this thing because it indents this thing, and you can't really do this. This makes no sense. So, because I use Alban braces, this kind of thing already looks bad with Alman. So you kind of have to do KNR style. And that is kind of problematic if you have to support different styles. So you could kind of say, you know, um, you could imagine this having a different style as well. But that's okay. That's not important. But you see, here's the let's look at the other places where this is used. I mean, it's not a worthless thing. It's just that how valuable is it? So I'm going to look at another one. Another one is actually in sub process, and it's this one. And this one in process, it's special because in this case we are returning an error here, but we do want to rethrow it. So we put the rethrow in here. And this is much simpler actually for with do. So I could convert this to do. And in this case, this one is a break. It's not weird. So it's just a break. And this one return is kind of normal. And again, this one is an error, so that's fine. And then we have like why did I do that? It's complete. It was completely unnecessary. You just need this break. So because this kind of it wants to do an easy an early exit, and kind of this kind of completely works. And I don't need to have the rethrow or anything complicated. Right, let's look at the other example. And this kind of what I would do to see if it's needed or not. So we have another one that's actually assigning something. So this is in the dynamic arena allocator. So again, it's also kind of it has this pointer that it wants to assign to. There are some places where it's done. Here it's early. It's done early, and it wants to exit. So that is why I picked this originally, because it has more than one exit point. It has actually one, two. Let's see if we have more. So we have 1, 2, 3 exit points here. So if we would have that one and do again something like we want the pointer. Let's see what to do with the pointer. In the end, that's what would return. So okay, so we have. Let's see if the part at the end, is it possible to? Okay, no, we can. Yeah, I need the pointer. So let's say we have the pointer, right? So it's a no in it, and we do another of these do things, and because the standard library uses Allen braces, we're going to use that, and we're not going to have a return here. So this is kind of dangerous now with that we're doing this, because it's easy to get it wrong. But now we have like, okay, the pointer has to be assigned, right, to this new thing. This is the new one, and then we're going to break, and we're done, right? We're already done with that. Now let's see here if we allocate now we have this actually labeled break from ifs, so which is kind of unusual. So again, we set the pointer to this new value, and then we break, and we should be done. Oh, no, it's in allocate new. So now again, be careful. So allocate. Let's have this. Let's say set done. Okay, we're gonna have this thing, and we're gonna break explicitly to set done. Set done. And here we allocate new, and then we're gonna set done. Right. So that's done, and then finally we have the pointer. Just like this, right? So actually, right, we don't need a mem anymore, right? That could be, oh, that's a void pointer. Yes. So we can say set this. So pointer equals start, and then we have the pointer here, and then we don't need to set it again. So now we're done, basically. So that was a very, very small change, and we got it. It fixed our problems. So let's see if we can find something that really says, oh, you should really have that kind of, we should really have that feature. Okay, here's another one. This one is, again, it's, let's see here, it's setting the standard error. So again, we're gonna have like no init here, right? And then we are gonna do a do. And what we see here is there is something odd, something that we didn't have before, and that is this case we don't have any other exits, we only have these value exits. So here we're going to do like std_r equals std_out, and then we're going to break, and then finally we have like std_r equals this. um, it's not that much more things to write, to be honest. So I wonder if I can find anything else that has. I mean, it's slick. I think it's pretty slick to have this. Oh, here we have something. Oh, have you seen this? This is testing the expression blocks. Here, you can't do this. So this is kind of crazy, right? So here we put this entire expression block inside of here, and then return true, and that turned that into an expression. Yes, we can't do this. Can't be done. Um, but we can make write a macro that does this. So that should be clear. So I won't try to do that. If you ever wanted to do something like that, I think you are crazy. Uh, no, not crazy, but it's you are exploring the language to its limits. Of course, this one here is just should just be a ternary, right? It's just a lazy ternary. That's missing. So again, this I guess this code is kind of hard to read, but we are getting there. So like this, I would add some parentheses so it's like easier to see. But again, okay, that's not something that we needed that feature for. And again, I picked the wrong thing to look at it. So here, let's see, we have, let's see, this one. This one seems interesting, and this one seems kind of interesting too. So let's look at those. So here is actually, what about the new value? So we know the new value here is going to be time. And so we can basically do this, right? And then we can do another do. And then we can, wait. What was that? Oh, we already have the value. Okay. Right, so in this case, it's different. So here we're going to get the overflow, and if it's true, we're going to set the value to the new value, and then we break. Another case, let's do the conversion. If it's less, then we have an error. Otherwise, we set the value to the new value. So value equals new value. And then we're done, and we don't need that thing either. So we don't need this extra thing with rethrowing. So it looks like doing this, and I'm just doing this just to see. We already converted pretty much everything in the standard library already. So we can just do like in here. Again, we can just set C here to that value. Or we just call it, yeah, C. Okay. And then we do these tests. And in this case, we are just going to make, wait, is the string, what's the value? Yes, this is a char, right? So again, we can set C to that. We can just do it like this, right? And then we can break. And in this case, again, this is actually where it gets a bit longer. But then we can do like this too, right? We can do a switch here. So set C. Okay, so maybe we can do like a switch case. If the base is not this, then we have that particular case, and we can just do this. And let's see what happens at the end. Oh, that's just a default, right? So we don't even need this. That was bad. So actually, if we start here, and then we just, if it's not base 16 and see, then we can just do that. Otherwise, and then we have next case, C is less than F. Then we're just going to do like C minus equals like A minus 10, right? This was the one that I made a mistake somewhere else. So I have to, yeah, I did minus, that should be right. And now I can even just make it one liner because, maybe like this. So KC is less than A. Now that's an error. It's just going to be like an error here, and that's going to be returned like that. If it's greater than F, then we again get yeah, and then we can do put those or in a single line, right? And then finally default is, C is minus A minus 10, right? So like that. And whoa, that's already done. That's how it should look. Maybe I've done something wrong here. I did kind of run the test. Maybe it just breaks everything. All right, we have something here. Okay. So the pointer, you can't set the. Oh yeah, so this one might be an arrow, so we have to put that one there. Let's see, something else. So sometimes the return values, you can return, and then you assume that. Let's see, everything passing. Right. So we had some lost kind of standard library things. And that was this one, needs escape, right? We talked about that one. I think we had that before. Now, we have the return false, and what we have, look, needs escape is down here, right? So we can do these again. So we have a for each, right? And in the case that we have one of these, then needs escape is going to be true, right? So so then we're just going to break from the for each, and check. So we're going to break from the check. Otherwise, it's going to be, wait. Let me have a look here. So it's, yeah, it's going to be, okay, that one's outside the for each, right? That makes sense. So it's going to break from the check. And now this is the place where we wanted that kind of, so we actually not going to have that. We have to have a do here. This is kind of where we want the else, right? Some people wanted me to add else, but you can have do. Okay, so we don't have this thing. We're gonna remove that. So instead, when you have the switch, it's going to break the check, and that's going to be like the everything there. And then otherwise return false. That means you're just going to do string append and then continue. And continue here is continue line. So continue line. because you didn't get anything like that. Yes. So okay, and otherwise you go here where you need to string append and do all these things, these janky things, right? Uh, and have these escaping back and forth. So maybe this works, maybe doesn't. I think that was correct. Let's see here. So if there's a tab or a space or a V inside of that particular command line, what we do, we're going to break, check space, white space, right? So we're gonna break the check white space. So if we don't have any white space, we're fine. We're just gonna append it, and we're gonna get the next line. Otherwise, we go in here and do like add these things here, escapes to those. As you have to do quotes around everything, and then we're done, and then we continue. So that looks okay to me. So let's see what's left. What's left in the nothing. That's all. We probably have something in the resources as well. So in the resources we have like this description. So let's look at that one. So it's a game report. So what is the answer here? And depending on what we had, we can return different things. So actually, this is one of the best uses, I think, of this that I can think of, because it has three possibilities. So it kind of looks good to do it like that, it's just returning here. So in this case, we have to have we do a switch again, but we can probably do it with a switch. So again, we do it with a switch. So this kind of if after if they're often easy to do with a switch. So then we set the description to too low, and otherwise, if it's greater, then we'll say like this: desk equals too high. And then otherwise it's default as a desk equals the answer, right? And we don't need to do, we're just done with that. And let's look. So we can kind of, the actual code is a little longer, but that was just because we had that. That's the no init thing that we added. So it's, you save a little, but you very rarely save anything. So here's the question here is like, do we want to keep this or not? And I am thinking like, actually that was a good idea to not allow this, because basically because it's not really used that much. It's not something. It also boils down to what I talked about before. So about having more syntax. So let me look at, and if anyone has some questions. So someone is asking about match expression in Discord. Okay, let me have a look at that. So what's the question here about match? Where did I put Discord? There we go. So okay. Oh, okay. So maybe I. So someone introduced lambdas to generate momentum. Okay, so lambdas in C3 they are not capturing. They are not closures. They are just anonymous functions. Also, I don't like closures because people misuse closures so much, and then they really mess up what they don't know how to manage memory. They just put things in the closure, and then the closure runs out of the memory is just corrupted, and they don't understand, and then they do all these complex things where you pass around closures everywhere, and it's hard to pass around closures because you need two pointers. That means you can trivially pass it to a lot of C functions. So with the C functions, basically you need the function and some data. And so if you want to have pass around instead of closure, you have the pointer and a function. Okay, so I think there was never mind. Yeah, the match expression. So okay, so I guess we could do things like just adding the match switch and have that return a value, but basically the value is very low because the only place where you really, really, really want to, do some things where you kind of match is in the case where you have an optional. So, but then in that case, there's there's like this kind of syntax in C3. So you have a special syntax for unwrapping things. But okay, let's talk about why is this not good. So why did I want to remove this? Someone complained about it, and I said let's remove that, and why did I immediately think like, oh yeah, maybe we should remove that? Because one of the things, like, I've been thinking about it a little, but this also it's ugly. In the sense that this looks like something new. We talked about that before. Like, this looks like new syntax that someone made up. It doesn't matter whether it's like readable or not. It's just like it's new. There is something new happening, and people have to figure it out. And so, what is the value? If this was possible to leverage this over and over again, that would be one thing. And if C3 had the old C macros, this would be super useful because C macros need this kind of thing to do anything complex. But we have semantic macros in C3, so we don't need this. There's absolutely no need for using this within a macro. That's just completely useless. So that leaves this just for the kind of cases where you now can use do. And this with assigning values, but as we see in the library, it's not very used that much. And there's a problem, like, how many people even know this exists? Not a lot of people, because they're not looking for it, because it's not a big problem that you need to solve. And that, together with this kind of alien syntax, so people are not using it, it's an alien syntax, and while it has uses, it's better than the alternative. Do is not as good as this. It 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 makes the language larger for very little benefit. And we want to make this again. We want to make the language as small as possible. If this had been possible, this kind of thing. This is what I wanted. This was the syntax I wanted, right? So I wanted syntax like this, right? If this kind of syntax. If this had been possible, then this would look pretty cool. I think this would be like, yeah, you're doing something that is like a small. It kind of says to a C program, you're making a small function inside of there, you know. But it's not possible because, well, I could do that, but then you do this all the time. Like, you do, if you have something like this, you really want to be able to just do, write something like this without the compiler complaining about it, like this. And you can't do that if you already said that this is an operator. And so, okay, let's say this is, and you have to say that this is a symbol in itself, so or otherwise the parsing just becomes crazy. So that's why I couldn't use that. So I kind of try different things. All these, let's have some fun. Not that I wanted to have, not that it was fun trying to figure out some syntax that looked okay, but this kind of thing. And you could also think, at this point in time, definitely this could work. Some static or something like this. We could even have this. This actually makes more sense. You could think like, okay, let's go. This is better syntax, because this is like, okay, let's have a mini function and kind of run it here inside. This makes fun. I mean, maybe I should just change the syntax of this and it just works. But again, we're going back to, if I look at the compiler, so we're going to have to like the expression block thing. Let's see if I can find this expression block. Analyze expression block. So let's see here. We have it in here, right? So we're going to do a bunch of things, unified returns and stuff like that. You have to do that anyway for the macros, but it's and then you have to think about the first in a different way, and yeah, maybe we can make something easier by removing it and so on. So and we go, once we have the expression block, by the way, then it's going to be here, and then we have the cogen. Let's look at the cogen for that. Copying it, of course. We're going to emit that particular thing. We're going to emit an expression block, and then we just do a bunch of pops, and it's not that bad actually. But yeah. So sorry, I'm tired. But removing it makes sense for that. It's like, yeah, it's a pity removing it, but yeah, it's also maybe not that bad. If I can just shelve these changes, and I'll just give you another look at that. So let's take these and shelve these changes. And let's go and look at something like the way it looked before, right? So we're now back in the I shelved these changes. So now we can go back to the library and again find a bunch of these, and we have this escape, and we can like, okay, what if it looked like this, right? Yeah, it could have looked like this, and that would be kind of okay. But again, we can see, okay, so there's a function that makes more sense that we have return. People kind of infer that, and then maybe we could say what the return time is anyway. But then we're dangerously close to having declaring a function anyway, so we'll kind of have to stick with this. A lambda, I mean. So we'll have to stick with something like this. I mean, or we just remove it. So that's the simplest thing, is just to remove it. One less feature, one less, checkpoint. And if people are like, oh, how do you do this? I mean, look at how nice our expression-based thing is, because you can do, a switch, and then you get the value of the switch or something. So yeah, I can't check that. I wouldn't be able to check that checkbox anymore, but Who cares about checkboxes, right? The nice thing about this was they can make anything into an expression, right? But but again, who is using this? Like, don't solve problems that you don't need to solve. If this was like a concatenative, we kept on doing like, oh, let's do something on this and then blah blah blah, and then you have something else, and then inside of that you can have this thing again, and then you create things inside. But if you do that in C, I will. You are crazy. You can definitely change things. Have that kind of thing going on in C3. But that's not code I want to make people write anyway. So, and you can't format that in any way that looks sane. So everything looks totally insane. So, well, if you can't even write it in a nice way, maybe it shouldn't be there. So those are my thoughts on that. So maybe it will go away. I'll give some more thought, and uh, um, that's pretty much it. Okay. So otherwise, and someone is writing. So Stefanos is writing. In otherwise, this is Newsy's compound statement expressions. Yeah, almost, right? So the Newsy is special. Gnusy is special. So uh, one of the things, one of the problems with the GNU expression is that let me just paste in what someone wrote, like Stefanos wrote. So he has this. This is the way it looks like. So it will be like, okay, int a equals like this, right? And then it has some else and stuff like that. The last thing in the expression, like the last thing, that's this one. This one is implicitly return. And the funny thing is, like, you can have a return in middle. So if you like have y is less than 0, then you can return, and that return would actually be like return in the middle of everything. So it's in the middle of that expression, of which something I try to avoid. So and you return here, so you can't go anywhere else. You can't return early. You can't do like this or something, which would be really nice. I mean, you could have this one would be like if it had been able to do something, you would have like this is probably what you wanted anyway, but you can't do that in necessity. And this actually is this one is ambiguous for for um, for us. So when you go and see this, it can be, I mean, in C, it's not ambiguous because you can never have something like this in the middle of something. You can do this, right? But you can't really have like a parenthesis and then something like that. If you have a call, like call foo, it's never this. It's never this. It's always like a my struct something. But in C3 you can have this all the time. So having this be something special is like no. You don't want to parse that as something special, which means all this like this syntax, which I've been okay, people would have recognized it. It's not okay either. So can't really have that in C3. And it's super useful in with GCC. It's not available in MSVC, so you kind of can't use it, even though it makes you really unhappy that you can't do that. But when you but it allows you to do really nice macros with GCC. But it's kind of a hack, and I was thinking like let's not make that hack. Let's have these expression blocks, and then you could write macros no problem whatever you want. But then I have semantic macros, so I don't have that problem in the first place. So yeah, it doesn't need to be there. Let's see if we have some other question. Okay, I think that's kind of I guess what I have to say, unless anyone asks me something that I can rant about. So yeah, I don't think anyone else has a question. Um, right. I'm just looking through the Discord now, seeing if someone has a question I can look at, but I don't think so. So this is going to be like a kind of short stream. I'm mostly talking about features, um, and maybe we'll remove this from at least might check this one in and have remove this thing from the standard library. And I mean, doesn't mean it's gonna go away. I can put the deprecation notice on it. I love removing things from the language. People love discovering new features in the language, but they also hate it when they have to learn the features in the first place if they are forced to. Um, I think like a language feature that isn't used, that's a waste. And yeah, maybe someone is like using this for a lot of stuff and they really can't do without it. I'll definitely would like to hear anyone who's using this a lot and what their opinions are, like how easy it is to use it with do and such. It does prevent you from using this kind of thing as well in the requirements. So, no, sorry, contracts. So, one of the things you could do with the is would be to get a contract, and in that contract you would require something, and then you would insert arbitrary code here, right? Because you can, because that's an expression. And yeah, although for readability purposes, you can't really put a lot of stuff in here, but you could do anything. You can have a loop or doing anything, but it's not very readable. So it's better to have that, put that in the macro, and you actually get the same code running, just that is not that cluttered. And I don't think from searching that I ever use this. And I don't recommend anyone for you using it either for that particular purpose. So, unless someone is asking me any other questions, I'll wrap it up. Okay, so thank you for watching. I'll put this on YouTube later, I think. There might be people wanting to hear more about these changes that might happen to the language in 0.7, and we probably it will be like at least for some features there will be the possibility to turn them on already in 0.6, but a possibility to just retain the old behavior, so people don't need to change their source code or anything, so just switch on the old code. So as usual, we can deprecate. We can deprecate things, but if these if we use braces for generics, then that's a breaking change that you can't really introduce without having, making a lot of um, making changes to the existing code. So I already allow people now to write this kind of code in let me see here, I can show you. So this cost used to be prohibited. So before you couldn't do like if I wanted to do this, now you not need to do this, right? So this was a standard way of doing it, but you weren't even allowed to use the cast syntax. So this would be like an error before, and now it's okay, basically. And what we want to do is kind of deprecate this completely, because once it's deprecated, you can start using we can start using this for actually generics instead. So this would be like a generic. Then we can do like then we would have these like list x like that, and then we would add like x push. It's not elegant, but it kind of would work. Better than having this anyway. No, bad. And by the way, it's like, again, this would be ambiguous, a bit too ambiguous to handle. This would be also, like, it wouldn't be semantically ambiguous, but you could construct something like this, and you would think like, oh, that's an array. But it isn't. It's a parameterized thing. There is a way around this, by the way. Okay, I'm let's go back. I was going to finish, but let's go back and say how you can actually save this kind of syntax if you wanted. So how would you go about saving this problem, this being ambiguous, right? So this is fine, you can figure it out, but the compiler here is not going to know when it's parsing that this is going to be an array. So you can save it as an array, and then you reparse this or something, and that's like really not very nice, but there is a way, right? One way is saying, okay, you have to start with a type. You can't just do this, you have to start with a type, whatever it is. So in some weird cases, you might do void because you don't want anything, it's just do that. So that's one way, and the other one is, have a prefix, right? So let's say number one. It's number one, right? Or it's whenever there's a constant, then there is like, okay, we have a this looks very bad because of that. Let's make it like so. So you can have like that. Okay, so now it's number one, right? We can even have like, that's a constant. No, we'll have something like this. Not very elegant, yes, but that's a possibility if you really wanted this kind of syntax. It's just, you can even have like, okay, well, right, you would have something, like a backtick or something. Now we're using that, so that's a bad idea, but %1. I don't know. Everything like this looks bad to me, but it should look bad because it's not supposed to be like that. So here we have, %1, %1, yeah. It will be really weird when you do like, but that's going to be rare. So that's a way to kind of make that work if you want to, or even at, or even this actually. So in this case, you can say, okay, so this is going to be like, bear with me. So it's a parenthesis, then it's like, if it starts with a parenthesis, it's considered a generic. Yeah, you can do that. But I don't recommend it. So I think in this case, like doing this is superior. So just have this. Like, people will probably be more happy. Like this. Now all these errors are making it look very bad, but like this. Okay. So good night, everyone. Have a great evening. If you are, um, if you're not too late and shouldn't go to bed now. So that's it. Now I am closing for reals.